Page 14 of quadratics. If V is the vertex, then find the equation of the quadratic function with these graphs. So this is kind of a continuation of before, but these are mostly in vertex form. Okay, so let's see. For this one here, I'm going to use vertex form. So it'll be y equals a times x minus 2 squared plus 4. And it happens to go through the origin. So one of the points on the curve is 0, 0. So I can find the a value by plugging in 0, 0. So I can put 0 minus 2, which is negative 2 squared, plus 4. So 0 is equal to 4a plus 4. 4a equals negative 4, so a is equal to negative 1. So if I was to rewrite this, I would say y is equal to negative x minus 2 squared plus 4. B. So again, they give us the vertex, so we're going to immediately write it as y equals a times x minus 2 squared minus 1. And one of the given points is the y-intercept 7, so 0, 7. So I'm going to put 7 in for y, and I'm going to put 0 in for x, so that gives me a times negative 2 squared minus 1, which is equal to a times 4, so 4a minus 1. And then I can add 1 to both sides, and I'll get 4a equals 8, so I know that a is equal to 2. If a equals equal to 2, then I can rewrite this in its final form, which would be 2 times x minus 2 squared minus 1. C. So for this one, y is equal to a times x minus 3 squared plus 8. And the x-intercept here is 1. So the point they gave us is 1, 0. So I can put 1 here and 0 here, and I'll get 0 equals a times negative 2 squared plus 8, which means that 0 is equal to 4a plus 8. 4a equals negative 8. A equals, divide both sides by 4, negative 2. So then I can rewrite this as negative 2 times x minus 3 squared plus 8. What about D? So this is obviously vertex form also, so it would be y equals a times x minus 4 squared minus 6. The point they gave us here is 7, 0. So we could put 7 in for x and 0 in for y. So we got 0 equals a times 7 minus 4 squared minus 6. So 0 is equal to 7 minus 4 is 3, so 3 squared is 9a minus 6. 9a equals 6. A equals 6 divided by 9, which is 2/3. So we can rewrite the function as y equals 2/3 times x minus 4 squared minus 6. E. So the vertex is 2, 3, and the given point is 3, 1. So we could put y equals a times x minus 2 squared plus 3. And then we could find the a value by putting 3 in for x and 1 in for y. So it would be 1 equals a times 3 minus 2, which is 1, squared, plus 3. So that would be 1 equals a plus 3. A is equal to, subtract 3 from both sides, you get a equals negative 2. And then I'm going to rewrite my function as y equals negative 2 times x minus 2 squared plus 3. Okay, last one. So the vertex here is a fractional mess. It's y equals a times x minus 1/2 squared minus 3/2. And my known point is 3/2, 1/2, so I could put 1/2 equals a times 3/2 minus 1/2, which is 1 squared minus 3/2. So 1/2 equals a minus 3/2. So a, I'm going to add 3/2 to both sides, so that would be 1/2 plus 3/2, which would be 4/2. So a is equal to 2. So my function is going to be 2 times x minus 1/2 squared minus 3/2. Consider the graphs of a quadratic function and a linear function on the same set of axes. Notice that we could have 3 types of intersections or no intersections. So we could intersect at 2 points, we could intersect at exactly 1 point, or we could totally miss each other. If the graphs meet, the coordinates of the point of intersection of the graphs can be found by solving the 2 equations simultaneously. Okay, it's just like when we have lines intersecting. The way we find the intersection of the lines is we assume that the x and the y in each of the lines equations are the same, and we solve simultaneously, right? So here is an example, 22, where we have this quadratic and we have this line, and the first thing we do is we assume that the 2 y's are the same, so we set the right side of the quadratic equal to the right side of the line. And then we just combine like terms, and it reduces into a quadratic, which we factor, and we find out that 5 and negative 3 are the x values which make that quadratic true. So, if we put 5 or negative 3 into the original equation, either this one or this one, then we can find that the y values are going to be 5, 2 and negative 3, negative 6, so the y values would be negative 6 and 2, right? Okay. All right. So, in this section, we're going to do exactly that. Without using technology, find the coordinates of the point of intersections of these pairs of functions. So each one is a quadratic together with a line. So let's do this for A. So x squared, and the first thing we're going to do is we're going to set the right side of the quadratic equal to the right side of the line, because we know that the y's are the same. And then we combine like terms. So we have x squared minus 2x, and we're going to subtract x from both sides, so we end up with minus 3x. And then we're going to subtract 6 from both sides to get rid of both of these terms, and we'll get 8 minus 6, and then we'll have that equal to 0. Now we have a new quadratic, which is related to the original quadratic, but it's not the same, right? And then we're going to figure out what the x values for this make this true. So it would be something like x, we're going to factor it, and we get x minus 2 times x minus 1. And so the 2 possible x values are going to be 2 or 1, right? And so the coordinates that make this intersect would be 2 comma something and 1 comma something. How do I find the something? I find the something by plugging it back into either one of the 2 sides here. It's easier to put in the linear equation, right? So x plus 6. So let's find out that the y value for the x coordinate of 2 is 8, right? Because 2 plus 6 is 8. I put the 1 into x plus 6, and that gives me 7. Okay? And I'm going to, after I finish with these, I'm going to take one of these and I'm going to graph it for you just so you can see what that means physically. Let's go to B. So B has this quadratic and this line. So again, the first thing we're going to do is we're going to take the right side of the quadratic and we're going to set it equal to the right side of the line. And then we're going to combine like terms and see when it's true. So negative x squared, we're going to subtract 2x from both sides, so 3x minus 2x is 1x. We're going to add 3 to both sides, so it's plus 9 plus 3 is plus 12. And so the right side becomes 0. Just because it's harder to factor when there's a negative sign at the beginning, I'm going to multiply everything by negative 1, including the right side. Of course, 0 times negative 1 is just 0, so I'm going to get x squared minus x minus 12 equals 0. Then when I factor this, I'll have x minus 4 times x plus 3 equals 0. Again, you can do this with quadratic formula. It just takes a little bit longer. And so the two possible solutions are 4 comma something and -3 comma something. Those are the two x values which make this 0, right? Now I just want to see what the y coordinate is that corresponds to this, so I put 4 in there, so it's going to be 2 times 4 is 8, minus 3 is 5. And then I put -3 in there, so 2 times -3 is -6, minus 3 is -9. So those are the two coordinate pairs which are intersection points for those two functions. Now we're going to do C. So now we have the x squared minus 4x plus 3 equals 2x minus 6, right? So x squared minus 4x plus 3 equals 2x minus 6. And I'm going to combine like terms. So x squared minus 4x minus 2x. We subtract 2x from both sides. That gives me minus 6x. We add 6 to both sides. That gives me plus 9 equals 0 because we've eliminated both of the terms on the right. Now we can factor this. It's just going to be x minus 3 times x minus 3, right? So our intersection point is just 3 comma something. 3 comma what? We can put the 3 back into here to find out what the y value would be. 2 times 3 is 6, minus 6 is 0. Okay? So this happens to intersect right on the x-axis. Let's go to D. So we're going to take the right side of both of these functions again, and we're going to set them equal to each other. So negative x squared plus 4x minus 7 equals 5x minus 4. Negative x squared, we're going to subtract 5x from both sides, so we end up with 4x minus 5x is negative 1x. We add 4 to both sides. Negative 7 plus 4 is negative 3. And so the right side is 0. I don't like working with a negative leading term, so I multiply everything by negative 1. I end up with x squared plus x plus 3 equals 0. And I don't know if this is factorable. I don't think it is. So we're going to have to use a quadratic formula. So x equals negative b, which is 1, right? Plus or minus b squared, which is 1 squared, minus 4 times a times c. So do you see how 1 minus 4 times 3 is 1 minus 12, which is negative 11? So the inside of the square root becomes an imaginary number, and so there are no real solutions to this, which means that actually this quadratic and this line do not intersect. So if they don't intersect, then I can't find the points of intersection. Okay, this is kind of a trick question because they said that to find the point of intersection, but there is no point of intersection. Okay, and just to show you what that looks like, I'm going to do one of these on a graph. Okay, on the calculator. I'm going to just do 1a on the calculator. So I input the left side and the right side. Do you see how I put x squared minus 2x plus 8 as y1, and I put x plus 6 as y2. I'm going to graph them. Okay, there's the quadratic, and there's the line hitting it twice. It hits it once at 1, 7 and 2, 8. I'm going to adjust the window size to take out some of the unnecessary parts of it, like the negative plane. And then I'll graph it again. Actually, we don't need too much of the fourth quadrant either. So y min, I'll put 0. Okay, and so basically it intersects 2 points there, right? And then I just want to show you that the relationship between this quadratic and this other quadratic that is formed when we combine the like terms. So the other quadratic I have put down here in y6. So I'm going to turn this one on also. Right now it's turned off, so that's why it doesn't show up. I'm going to turn it on by pressing enter on the equal sign, and then I graph it, and then I'll have all three functions. So do you see how the x coordinate of the intersection here lines up with where the new quadratic crosses the x-axis? So that's 1, 7, right? And 2, 8, which is the intersection here, lines up with where the new quadratic crosses the x-axis. So this other quadratic that we form when we combine the like terms, it is not the same as the previous quadratic, but it's kind of like an indicator function which crosses the x-axis whenever the left and the right functions match. This left function and this right functions. When they match each other, their combined function becomes 0. Okay? So that's kind of how it works. So be careful. It's like a lot of people, once they find the 2x coordinates, sometimes they'll plug it back into the new quadratic. And of course, they're always going to get 0, right? The only way you're going to get the real y coordinate is if you plug it back into the linear function or the original quadratic function. So that's it for this section.